Well, thanks for having me here. I've got about an hour's worth of slides. Sorry, I'm just. So a little bit of background on Don't Panic Labs gives a little bit of context. So we're about 40 people just down the road here on 14th and Q, and we do a lot of initial versions of software technology, a lot of times for startups and entrepreneurs that don't have a technology partner. And we also do product inventions for companies that have core technologies or products that are aging and they don't have the ability to kind of transition those to new technologies. And we do about 10 to 20 projects a year with that staff. And over the course of our lifetime, we've had about 100 plus interns rifling through there. So what's interesting, the labs portion of Don't Panic Labs really comes true. We're iterating so quickly on new projects and new problems that it really reveals both kind of weaknesses in our processes, but allows us to experiment and refine those things along the way. So we started, when we formed Nebraska Global, part of our goal was to create opportunities for students coming out of the local universities to work at small software tech companies. And so we have quite a bit of experience of what it's like bringing them on board. And by and large, they understand the knowledge of their field of discipline, right? That has never been the problem. Where the problem has been that they're all prone to significant errors and judgments. Conversations where you might explain something to somebody and say, this is what we want you to do. Very bright person, they come back and you're like, well, you realize that would never work. You know, this is not going to happen, and you didn't think about this. And the other problem is around internships and experience the students have. I'd love to say that anytime these students get out and they kind of get experience in industry, that's going to give them some context of the way that things are done. And particularly in the software world, that's just not the case. The quality of these internships varies widely. So it's not something that we can really rely on from an educational standpoint. And the key here is that companies like ours, which I don't think we're that unusual, we can't afford to have a long ramp-up time before people are being productive. As a matter of fact, without exception, up until just a few years ago, we would not hire a college graduate unless they had interned for us, which significantly reduces the field of possibilities. And unfortunately, if people don't get a chance to intern for us, then we'd had to turn them away and have them go somewhere else to get some experience there. So I want to give some examples of what kind of these errors and judgments are. So a lot of times I have them in two categories. One are failures, right? Failures to recognize incomplete or ambiguous requirements, just not seeing the additional questions that they need to ask, or not really understanding what a good requirement is or a bad requirement. And maybe even more insidious is this failure to recognize implicit assumptions that they're making. They don't even realize this, especially when we're relying on verbal communication, things like that. I think there's all kinds of implicit assumptions we're making about what somebody means or what needs to be done, or maybe they just completely didn't think something was relevant. And then they're really reluctant to seek help from others. This is something we have to almost beat into the heads of our younger people, is we almost have to tell them, this is how much time we want you to spend on something before we want you to come ask for help, because engineering is a team sport. This is not meant to be something we do in isolation, but we also want you to try things a little bit before you come ask for help. And then the other category is things we see as biases. This idea, I'm just going to leap in. I got it. You told me to do this. I'm leaping in. I'm doing it. We're skipping all kinds of possibilities or opportunities for critical thought. Or they just focus on what we call in software the happy path. You know, I need to get from A to C, and I just go the straight path of what the nominal use case is for that, and don't think about anything else that could possibly go wrong in the environment or the way the user looks at the system. Testing about, if you ask people what the purpose of testing is, 9 out of 10 will say to verify the thing works. You're asking somebody to build something that works, and then you're asking them to switch gears and say, now try to break what you just built. And that's something that doesn't come natural to people, and it's something that has to be taught and a skill that you need to kind of develop over time. And then this other thing where it's like, hey, I just made this change. Did you test it? No, I mean, what could go wrong? I think it's going to be fine, right? So this whole YOLO, I looked at it, it'll be fine. Now contrast that with what I consider to be like valuable, experienced engineers. This is the sort of thing, and this is not really a complete list, but it does give you a sense of the sort of skills and experience that people develop over time. This idea of, hey, not only am I listening to what you're saying as a stakeholder, but I'm like putting myself in your shoes and trying to understand. I want to be a proxy for you as I'm trying to solve this problem. So this idea of stakeholder empathy, being able to what we call see around corners, to hear what somebody's saying, or to see a requirement, or to see a potential solution, and to immediately be thinking about, okay, that might work for now. Where will this go wrong, or how might this need to evolve over time? This understanding the importance of a shared understanding, this idea that we all have hidden assumptions, and if we rely on verbal skills and things like that, they understand the need for processes, models, methods, and to have some discipline and structure, which is really difficult in the software world because people feel like when you talk about this, they're like, well, where's my creativity? You're not allowing me to just do whatever. Well, software is not an art form, right? It's an engineering exercise, and it requires that discipline. And then they also don't oversimplify complex problems. They immediately try to look for where is the complexity in the system. This has got to be more difficult than this. So that's really what we're looking for. So when I think about when I try to boil down what I think we're getting out of the education institutions now, I think we're doing a great job of teaching them how to use the tools, right? They know how to use the hammer, the drill, the radial arm saw, the table saw. They're great at that. But I can't ask them to build anything more complex than the doghouse with that, right? They don't even know where to start, right? So how do I get to that? Well, I mentioned that we up until recently, we're only hiring people who'd intern for us. And recently we've been able to change that. So which expands our ability to hire people in general, because now we can take people from anywhere, right? Regardless of whether they have some knowledge of the way we do things. The reason we were able to do that is that over the years, we've put a system in place. Which is in software, it's kind of hard to do because there's all kinds of forms of best practices but nothing that really stitches things together from requirements complexity all the way to solution complexity and how we do things. But the whole engineering discipline around what we're trying to do is to try to create process and methods and checks and balances and patterns so that we leave as little to chance as possible. And when we do that, we get some benefit. Now we have some structure for even a young person can kind of come in, and even though they're prone to errors in judgment, we've got a safety net there. We have some guardrails. We've reduced the solution search space a lot of times for them, so they're not overwhelmed by all the possibilities of how to do something. And we get more predictable outcomes from this, right? Which is really what we all want, especially in software. But the system also creates some context for how you can educate people too. You start teaching them a pattern or a method or something like that. They can relate that back to this overall structured discipline. So now that stuff is meaningful to them, what they're learning, as opposed to some other organization, more of a cowboy culture where it's kind of ad hoc. Everybody's inventing their own practices. There's no standard. There's no identity for how we design and build systems. And I realize in other engineering disciplines, there's probably not this problem. In software, we're still pretty immature there. So I talk about some things that I think could help, kind of keep all that stuff I talked about in your mind here. The first is things that I think we could do on the educational side. So I would love to see more focus on the processes, tools, and methods for analyzing, designing, testing, deploying, maintaining complex systems, not just small problems, but arm them with a framework to do problem solving, right? That they can repeat. It may not be exactly what we do at Don't Panic Labs, but I can assure you if they come in, they'll recognize our system and say, okay, this is a little different than what we've done before, but I understand the reason why we're doing all these things. And I understand the importance of that. And interject a variety of critical thinking techniques and tools. Just get them away from thinking that if I don't have fingers on keyboard, I'm not being an engineer, I'm not being a software developer. Really instill that in them. Give them some idea what they should expect in industry. Like I was having a conversation the other day, we were talking about the role of a product manager, which is a fairly technical role. I had to be years in industry before I even heard that, knew what that was. I think it would be important for the students to understand these are the typical roles in this industry, and this is what they do, and this is typically why they might choose to do that. I'll be honest, when I came out of school, I really didn't know what an electrical engineer did. And so, I I got into the field because it was just intriguing to me. It was mysterious. I didn't know anything about it. And it took, a while for me to kind of figure out kind of what my role was. And then also give them some context for the coursework they take. I bring up engineering economics because I have two mechanical engineers in my family. They both complained about this class. And I'm like, why do I got to take this engineering economics? I'm like, that is an incredibly important class. You have no idea how, there's a business to engineering, right? And it's very important that you have this, but they just, they didn't really know. I'm learning all this stuff. They made me take it. I don't really know why it's useful. Now on the experience side, I'd love to see more and multiple experiences on unconstrained, messy design problems. First and foremost, it doesn't matter whether they ever make it work, right? It matters that they tried and failed and struggled and to get this thing going within the context of that problem-solving methodology that I talked about, right? And so, because everything is messy in the real world, there's all kinds of ambiguous requirements. Make sure that give them trade-offs, requirements that are in conflict with one another, so that they understand the need to do trade-offs and how they evaluate it. It doesn't matter what they end up doing, right? Make failure more of a part of learning, not that the fact that they got the thing to work, but more about what was the process they went through to do that. I think it's important to both build new systems as well as give them a system that they're not familiar with and tell them you got to change this system to do something else, right? And you got to figure that out. The next thing is troubleshooting systems. I think it would be great if there was, give them something that doesn't work and have them figure out how to do it. Now, you're not going to make an expert troubleshooter out of them, but I go back to some of my initial experiences in industry. I was responsible for a missile program that didn't work, and I spent years making it work over 2 years. Handed it off to the next guy, and I realized he'll never understand that system as well as I do because of all the troubleshooting I did. And then finally, we really have to promote kind of rigorous, disciplined, structured ways to think about testing. It's definitely a weakness in software. So I think I ran over a couple of minutes there. Not quite. Didn't take all your time, but that's all I have. Thank you. I look forward to the questions.